How you doing, guys? It's Emil with the Oliynyk Lab here again today. We're doing something different. We're doing a little bit of a face action in the top right corner. Anyways, today we're gonna go over a little in-lab software that we've developed. It's called XRD Match Web GUI. It's really just XRD matching. So pretty much, well, firstly, let me start off by saying it was first established as a website. Since then, there have been some updates to the Dash platform in which we can no longer host it properly. So at the moment, the only way to currently run this is locally, but it's incredibly simple. Firstly, you start off by simply downloading a zip, right, just like that. And then we will drag it right over here just for visual sake. Then you're going to want to open your terminal. Hold on, I have another one open that I got to delete. Okay, perfect. So now you have your terminal open. Terminal in MacBook. If you're working on Windows, PC, whatever operating system, it'll be PowerShell for Windows and whatever else for Linux, etc. So you want to navigate over to where your folder that we just downloaded is. So cd desktop XRD Match Web GUI main. Right. Now, I tend to do my work. I tend to have my dependencies installed with Conda. You could also do a variety of other different package dependency things. So mine are all in Conda, right? So for example, if you just wanted to start off here, you just do pip install our requirements, but I have everything satisfied, so it's pretty quick, right? Because most of them are already installed, and that's pretty much it. From here is simply type python app.py, copy and paste the link into Safari or Microsoft or whatever. So for this, all you do is you select the CIF files first, and I already have some experimental data that I like. So I'll go here, then I'll go to the folder. I'm looking for 284. And I'll just select all of these. There is one limitation, that's you can only upload 6 at a time. But for the most part, it should be all right. So once you load in your experimental XY data, it's labeled here. You could select, deselect, whichever. And the experimental file is named after what the actual file name is locally. So from here, we could see that this is a pretty good match, and you could start to lower certain lower certain intensities to make it match even better, like this. And you could shift it right by decreasing the unit cell, or shift it left by increasing the unit cell on the right. I know it's not apparent, but that's how it works for the time being. Right, and we're pretty much just going to continue with other ones. We follow the same sort of process. And we've also introduced a new feature to lower the actual experimental intensity. So this actually makes it sort of normalizes it in a sense, makes it less noisy while simultaneously lowering it depending on sort of interference and everything else. So you could fine tune it continuously, right? Very simple, lower, increase. Also change the cell parameters. This is more of a sort of advanced type thing. We just left it in case people see the need for it. And sorry, I'm just trying to fine tune this. And you can see a lot of good stuff so far. Pretty much a good match for a variety of different things here. And what is especially interesting that I've recently added is the option to, well, not just add and remove, but it sort of keeps track of what you add and remove in a sense. So for example, if you want to add in new CIF files or remove certain CIF files, when you add it, it'll come in and it'll save the parameters of the previous ones as well. You could shift it right or left, and then you could delete it simultaneously, and it still maintains your previous settings with your other CIF files, which we found to be pretty handy. You could adjust the range, left, right, however you want it to be. And you could also download the plot, and it saves it locally, pretty high res. I think it's about 300 dpi, just like this. So there's you know, it's really good to just couple it with you know, sort of paid programs like Match, in which you need to identify it, right? So you couple this with SEM, EDX, and really look for your phases. So the standard wavelength here is set to copper K alpha. However, we do have the option to change it. You do have to go sort of under the hood here. So when you want to, also of note is that at the moment we don't really support site mixing. So it just automatically sets it to 1. So you're gonna have some problems with the intensity scaling. Now, if you want to change it from copper K alpha, it's pretty simple once I actually find it. Yeah, okay, so it should be in preprocess.py. So the selected wavelength of copper K alpha is 1.5414. You can add additional radiations if needed. I think I do have it somewhere. Actually, I think they might be removed. But you can always change it, the selected wavelength to whatever values you need, and go from there. You don't need a particular you know, fancy code editor or anything. You could sort of just open the file as is. I think the standard here would be text, just like this, and that's it. But yeah, so this is a little short crash course. If you do want to shift the cell parameters, they do standardize to like about 0.1, I think. So you'll see them shift right or left or however else. And you have a handy reset option as well that resets the cell parameters, doesn't reset the background intensity scaling or the unit cell shifting. So this is, yeah, really handy. If you guys ever come across any ideas, anything you want to improve, please feel free to put that in the comments section. And yeah, thanks for watching. Please feel free to reach out if you have any questions, anything else from there, and I'll see you next time.